P of A over B is nothing but P of A intersection B divided by P of B. P of A intersection B is 0.25, which is nothing but 1 by 4, and P of B is 0.5, which is nothing but 1 by 2. Solving specific problem. So probability of solving specific problem, that means either it can be solved by A or it can be solved by B. The total number of outcomes in throwing 2 dice is 36. But we need an event where when you throw a dice, the number appearing on 2 dice are different. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are revising the chapter probability. So let's see the weightage of content in this chapter. So in this chapter, you will be having one MCQ, one fill in the blank, 2 marks 2 question and 3 mark 1 question. So overall you can expect 9 marks from this chapter. Let's take few objective type of questions. If A intersection B is empty, then P of B over A or P of B conditional A is 1 by 2, 1, 0 does not exist. Now, probability of B over A can be written as probability of A intersection B divided by probability of A. Now, since A intersection B is empty, probability value is 0 divided by probability of A, which will be equal to 0. Hence, option C is the right answer. If A and B are any two events such that P of A plus P of B minus P of A and B equals P of A, then P of B over A. We know that P of B over A is given by P of A intersection B divided by P of A. Now here if we solve this equation, we can see here P of A cancels on both sides and we will get P of A and B is nothing but A intersection B, that is equal to P of B. So instead of P of A intersection B, we can substitute P of B here. So we will get P of B by P of A. Options are 1, 0, P of B over P of A does not exist. So option C is the right answer. Next, if P of A is 0.4, P of B is 0.5 and P of A intersection B equals 0.25, then P of A over B is, so here options are 5 by 8, 1 by 2, 1 by 4, 3 by 4. So let's see, P of A over B is nothing but P of A intersection B divided by P of B. P of A intersection B is 0.25, which is nothing but 1 by 4, and P of B is 0.5, which is nothing but 1 by 2. So if we cancel this, we'll get the value as 1 by 2. Hence option B is the right answer. Next, if A and B are independent events such that P of A is 0.3, P of B is 0.6 and P of A and not B is 0.12, 0.18, 0.28, 0.42. We know that if A and B are independent events, then A dash and B dash are also independent events. So hence P of A and not B is nothing but P of B dash, which can be written in the form of P of A into P of B dash. And P of A is 0.3 here. P of B dash means 1 minus 0.6, that is 1 minus P of B, which is equal to 0.4. Hence, if you multiply, you will get the value as 0.12. Hence, the answer is option A. The probability of obtaining an even prime number on each die when a pair of die is rolled. We know that when a pair of die rolled, sample space contains 36 outcomes. And the only possibility of getting even prime number on both die is 1, that is 2, 2. So we have only one favorable outcome, hence the probability will be 1 by 36, that is option A. So rest of the options are given here, 1 by 6, 1 by 18 and 1 by 4. So option A is the right answer. Next, we will move on to 2 mark question. A die is thrown, let E be the event, the number appearing is a multiple of 3 and F be the event, the number appearing is an even. Then prove that E and F are independent events. Now first let us consider the probability of E, P of E. So when a die is thrown, the total probability or the sample space contains 6 outcomes. So the number appearing is a multiple of 3 means we have 3 and 6 as 2 outcomes. So therefore 2 by 6, which will be equal to 1 by 3. Now probability of an event F. So the number appearing is an even. So there are 3 even numbers, 2, 4, 6 out of 6 outcomes. So therefore, if we consider the events 2, 4, 6 with number of sample space, then it is 3 by 6, which is equal to 1 by 2. Now let's take E intersection F. So the number which is both multiple of 3 as well as even number is only 6. So therefore, probability of E intersection F will be equal to 1 by 6. Now let's multiply P of E into P of F. So we will get the value as 1 by 3 into 1 by 2, which is equal to 1 by 6. So clearly, P of E into P of F is equal to P of E intersection F. And hence, they are independent event. So this is the definition of independent events. That is, the probability of E intersection F is equal to P of E into P of F. Next. If A and B are two independent events, then prove that the probability of occurrence of at least one of A and B is given by 1 minus P of A, P of B dash. So now let us consider the LHS. So probability of occurrence of at least one of A and B can be written as 1 minus probability of A union B whole dash. So this can be written as 1 minus probability of A dash intersection B dash. Since they have clearly given it is an independent event, so probability of A dash intersection B dash can be written as probability of A dash, probability of B dash. So hence proved. Next question. If A and B are two events such that P of A is 1 by 4, P of B is 1 by 2 and P of A intersection B is 1 by 8, find probability of not A and not B. So probability of not A and not B. So this can be written as probability of A union B whole dash, which can be written as 1 minus probability of A union B. Now 1 minus probability of A union B can be written as P of A plus P of B minus P of A intersection B. So which will be equal to 1 by 4 plus 1 by 2 minus 1 by 8. So if we take the LCM here, it is 8 divided by 4 2s are 2 4s are 8 1s are. So the value will be equal to 1 minus 5 by 8, which is equal to 3 by 8. Next question. Given that events A and B such that P of A is 1 by 2, P of A union B is 3 by 5 and P of B is equal to K, find K if A and B are independent. If A and B are independent events, then probability of A intersection B will be equal to P of A into P of B. A intersection B is not given here. So here let's consider P of A union B because the probability of A union B is given. So this can be written as P of A plus P of B minus P of A intersection B. And here P of A union B is nothing but 3 by 5. So P of A is 1 by 2. P of B is K. And P of A intersection B can be written as P of A into P of B. So here this can be written as 1 by 2 plus K minus 1 by 2 into K. So here let's shift half here. So we will get 3 by 5 minus 1 by 2. I will take K common factor here. Then it is 1 minus 1 by 2. Here this side it becomes 1 by 2K. So let's subtract this. So 3 2s are 6 minus 5 by 10. So that is equal to 1 by 10 is equal to 1 by 2K. We can also cancel 2 1s are 2 5s are. So therefore the value of K is equal to 1 by 5. That is the probability of B is equal to 1 by 5. Next. Probability of solving specific problem independently by A and B or 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. Now, given the probability of an independent event. So, we are supposed to find the probability of solving specific problem. So, probability of solving specific problem, that means either it can be solved by A or it can be solved by B. So, which is nothing but the complement of probability of not solving the problem. That is, this is equal to 1 minus probability of A union B whole dash. Now, probability of A union B whole dash can be written as probability of A dash intersection B dash. Now, since they are independent events, this can be written as P of A dash into P of B dash. Now, they have given probability of an event A is 1 by 2 and event B is 1 by 3. So, therefore, if we need probability of A dash, then it is 1 minus 1 by 2, which is 1 by 2. And if we need probability of B dash, then it is 1 minus 1 by 3, which is 2 by 3. So, substituting here, we will get 1 minus 1 by 2 into 2 by 3. So, which is 1 minus 2 divided by 6. So, if we cancel this, again this is equal to 1 by 3. So, the value is 2 by 3. Next, we'll move on to the section of 3 marks. Bag 1 contains 3 red and 4 black balls, while another bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. So, now let us consider the event E1 for bag 1, E2 for bag 2. So, what is the probability of choosing bag 1 and choosing bag 2? So, that is both are equal to 1 by 2. Next, let A be the selection of getting red ball. So, event getting red. Now, what is the probability of A over E1? That is, what is the probability of red in bag 1? That is 3 divided by 7. And similarly, what is the probability of getting red from bag 2? So, that is 5 red ball out of 11 balls. So, which is 5 by 11. Now, I am supposed to calculate the probability of taking red from bag 2. So, that is, we have already chosen red, but it should be from bag 2. So, that is probability of E2 over A. So, this is what we need to calculate. Now, this can be written using Bayes' theorem. E2 over A can be written as probability of E2, probability of A over E2 whole divided by probability of E1, that is the total probability A over E1 plus probability of E2, probability of A over E2. So, now the values of E2, A over E2 is given. So, E2 and E1 is 1 by 2, A over E2 is 5 by 11, A over E1 is 3 by 7. So, here we have 1 by 2 into 5 by 11 whole divided by 1 by 2 into 3 by 7 plus 1 by 2 into 5 by 11. We can remove 1 by 2 in both numerator and denominator. So, then we are left with 5 by 11 in the numerator. So, cross multiply 11 3s are 33 plus 7 5s are 35 divided by 7 11s are 77. So, here we have 11 1s are 11 7s are. Cross multiply 7 5s are 35 divided by 35 plus 33 will be equal to 68. So, this is the value. Next one, an insurance company insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. The probability of accidents are 0.01, 0.03 and 0.15 respectively. One of the insured person met with an accident. What is the probability that he is a scooter driver? First, let us see the probability of scooter drivers, car drivers and truck drivers. So, let us choose the event as E1, E2, E3. Now, probability of E1. So overall they have insured 2,000 plus 4,000 plus 6,000, 12,000 drivers. So among them, probability of scooter drivers is 2,000 by 12,000. So which will be equal to 1 divided by 6. Next, probability of car drivers will be equal to 4,000 by 12,000, which will be equal to 1 by 3. Next, probability of truck drivers, E3, is 6,000 by 12,000, which is 1 by 2. Now, let A be a person met with accident. Now, what is the probability that he is a scooter driver? So, they have given the values as 0.01. And probability of A over E2 they have given. So, that is equal to 0.03. And probability of A over E3 is also given. That is 0.15. Now, I have to calculate the probability the person who met with as an accident is a scooter driver. That is, I need to calculate probability of E1 over A. Now, using Bayes' theorem, we can calculate probability of E1 over A as probability of E1, probability of A over E1 divided by the total probability. That is, probability of E1, probability of A over E1, probability of E2, probability of A over E2, plus probability of E3, probability of A over E3. So now let us substitute the values. So 1 by 6 into 0.01 whole divided by 1 by 6 into 0.01, 1 by 3 into 0.03 plus 1 by 2 into 0.15. So, and evaluating this, we'll get the final value as 0.01 divided by 0.52, which can be written in the form of 1 by 52. Next question. A die is tossed thrice. Find the probability of getting an odd number at least once. So, probability of getting odd number is nothing but probability of not getting an even number. So, first let us find the probability of getting even number thrice. Now, probability of getting even number so once 1 by 2, second time is also 1 by 2, third time is also 1 by 2. So therefore the total probability is 1 by 8. Now probability of getting odd number is nothing but the complement of probability of getting even number. Now we know that probability of getting even number is 1 by 8. So this will be equal to 7 by 8. Next question. Given that the two numbers appearing on throwing two dice are different, find the probability of the event. The sum of numbers on the dice is 4. So we know that the total number of outcomes in throwing two dice is 36. But we need an event where when you throw a dice, the number appearing on two dice are different. So therefore, we are not considering the outcome 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So therefore, if we consider that as an event E, then the probability of an event E is only 30 out of 36. So we are considering only the numbers which are different. So now here we have 30 over 36, which can be written as 5 by 6. Next, find the probability of the event sum of numbers on the die is 4. So if I consider F as an event, so the outcomes which clearly shows the sum of numbers on the dice is 4 or 2, 2, 1, 3 and 3, 1. So, clearly it is 3 by 36. So, which will be equal to 1 by 12. So, now we have to calculate the probability of an event that the sum of numbers on the dice is 4. So, for that we need E intersection F. So we know that there is no 2, 2 in an event E because the numbers appearing on the 2 dice are different. So therefore E intersection is 1, 3 and 3, 1. So now we are calculating probability of F over E. So that means event E is already happened, F we need to calculate. So using the formula, we have probability of E intersection F divided by P of E. Probability of E intersection F, here clearly it is in the form of 2 divided by 36. So we can write it as 2 divided by 36. And P of E can be written as 30 by 36 as 36. 36 cancels. 2 1s are 2 15s are. So the value is 1 by 15. Next question. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that is actually 6. So first let us consider E1 and E2 as throwing a 6. So the probability of E1 is 1 by 6 and probability of E2 will be 5 by 6. So let A be the event so that he speaks the truth. Then probability of A over E1 is 3 by 4 and probability of A over E2 is 1 by 4. So when it is actually 6, it is 3 by 4. When it is not 6, it is 1 by 4. So now we need to calculate the probability of E1 over A. So again using Bayes' theorem here, probability of E1 over A can be written as probability of E1, probability of A over E1 whole divided by the total probability, that is E1, probability of A over E1 plus probability of E2, probability of A over E2. So let us substitute all E1, A over E1. So which is 1 by 6 into 3 by 4 whole divided by 1 by 6 into 3 by 4 plus 5 by 6 into 1 by 4. So clearly we can cancel 6, 4 in both numerator and denominator. Then we are left with 3 divided by 3 plus 5. So that is equal to 3 by 8. So this is the probability so that the man says it is actually 6. So in this session, we have revised the chapter probability. So this completes all the chapters from the second PUC. I hope you're happy with the revision classes. I'll meet you in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.